Here's Aviv Cohen with us, and you are going to talk for Voltaire.
Hi, Aviv Cohen, Voltaire Product Management. I'm excited to be here today with Sun and quite a few of our customers. We heard just yesterday DLR, Airbus, and Arscan. Today we're going to hear Clemson all join Sun and Voltaire customers. I wanted to open up with those who don't know Voltaire and just let you know a little bit about it, but generally we're going to speak about HPC in Wall Street, which is kind of a little bit out of the subject that other people were talking today. So Voltaire has been doing quite well in the past years, and actually we've gone public in NASDAQ this summer. We partner well with all the major server OEMs, and Sun is a dear member of that group. We have our headquarters in Boston and R&D center in Israel. Regarding our portfolio, the main building block, what we provide is InfiniBand-based switching solutions for high-performance computing, and we enable the unified data center. What you see is our grid directors, multi-service switches, fully redundant, that have 288, 96, and 24 ports, as well as IP and Ethernet gateways and fiber channel gateways embedded within the switch. Also, we provide blade chassis custom solutions, and we resell HCAs and cables as a full solution. But the interesting fact about Voltaire is that for every hardware person we have 5 software people. And so aside from working with the open community in OFED, we have our own application acceleration libraries, which I will cover later on. We have GridStack, which is the OFED stack distributed and supported by Voltaire. And we have a suite of fabric management software, which is element management, subnet and fabric management, and a top layer product for automation and virtualization of the grid. All of this equipment was tested in the Burlington Sun Lab, and we got the Solaris Ready logo, and we appear on the Solaris Ready web pages. So I wanted to talk, before we go into financial services, a little bit about how InfiniBand was used with regards to application. So I believe all of you know the Tokyo Institute of Technology deployment. It's been run a few times in the past years. Aside for the 1,300 nodes that are there, the cluster is used for the 1 petabyte storage I/O, file I/O with Lustre. And so initially, MPI was the only use of InfiniBand. Now it's file system, and the demand there is really rocketing. And less known is the fact that this cluster also uses the gateways between InfiniBand and Ethernet, creating a converged fabric. Again, the project with Sun, NEC, and Voltaire. Now, InfiniBand is kind of spreading not only with its uses, but also in the verticals. You can come to the Voltaire booth at the show, and you'll see how we align our marketing around these solutions for each vertical. So we started with government and research, on to manufacturing and energy, life science and entertainment. But the interesting and exciting vertical is right here. And this vertical is known to be quite conservative with regards to new technologies. And I'll tell you why they're opening up to InfiniBand and high-performance computing. So before we go into that, we need to understand their need. What is their problem? Why didn't they need it beforehand, and why do they need it today? So if you talk about an exchange architecture for market data, what you see here is the usual stack. You have farms for order routing, matching engines for the orders of the stock, and a ticker plant. And all of them are quite a few machines that are linked together. Now, with Ethernet today, the stack goes a kind of hurry up and down, which creates a lot of queuing, a lot of context switching, and the resulting is a delay. A delay which the competition can beat. And it can beat it because of a few measures. So let's assume, again, seeing it through the application, all the algorithmic trading that is going on today in the world, everyone has more or less the same algorithm. So when you want to buy, everyone wants to buy. So first, who has the right information, the timely information in real time? And secondly, who gives his buying order first? And so we put here 1.1 millisecond. We're talking particles of a millisecond difference in whether you win the business or you don't win the business and you don't do the deal. What we've done in Voltaire, jointly with Mellanox, hardware offload capabilities in UDP, we've created a library. And so when we actually change the transport, we take off a lot of the overhead and dramatically improve performance. So you get 3 to 5 times reduction in latency. And latency is the problem. So at this point, well, actually, I'll just go and show you how it looks in the constellation there. So you have Ethernet coming in, 10 gig coming in. You have the Voltaire, a redundant high-speed, low-latency backplane with all the 3 steps there, and Ethernet coming out. And again, the message is that Ethernet is the interconnect. And what we get, and I think this is the real point to mention, is an unmatched business-affecting competitive advantage. And this is where amazing things happen. People open their hearts. People open their wallets. The same people that said infini what or infini not, they're saying bring it on, to the extent that they order the equipment for the proof of concept and pay for that. And the thing is, what they get is the highest precision. Because again, if a part of a millisecond passed, actually a deal was made, and you don't have the current information to base your algorithmic trading and your trading at large. Also, since the method that everything works here is multicast, right? The broadcaster and the subscriber, the reliability of the network, that's an InfiniBand inherent character, is very important. And I'll drill down a little bit to that. So you have a multicast message going out, and then those that don't get it send a NAC, and you need to send that again. And then the congestion gets higher, and you get more NACs, and it's like a NAC storm. So having a reliable transport is very important. And so what we get is amazing, exciting performance of 4 times the message rates and 1/10 of the latency and 1/10 of the cost if you consider it to a general SMP machine. So what have we done with Sun in this respect? And we've done a benchmark in Melno, taking actually running the same configuration over Ethernet, gigabit Ethernet, and the Voltaire gear, and we got an amazing performance improvement of 50% in what matters. And what matters, since the messages are very small, is the transaction per second per configuration. So you see 50% here, and an amazing reduction of 30 to 50% in the latency. And that is something, again, that matters. That is something, again, that drives business. And so what I'd like as takeaway from this short talk is Voltaire is a partner to Sun. We enable InfiniBand-based grid solutions. We have a combination of hardware, software, and the people that are integrated with Sun solutions, and we support Sun globally. The second bullet is that high-performance computing is expanding. More people are seeing the appeal. There are more opportunities, and the financial sector is a big opportunity. A lot of exciting things are happening there as we speak. That's it. I'd like to take any question. I'll be available later on if you have any comments or questions.
Go ahead. Any question for Aviv?